So pseudo forces. What is the meaning of pseudo force and when this force comes into the picture? So basically pseudo forces, they are used, ठीक है ना, when you are doing calculations from the non-inertial frame or accelerated frame. So first we have to understand the meaning of, if you look at frames, two type of frames are there. Or one is called as inertial frames. One is called as inertial frames. Inertial frames. And second is non-inertial frames. Non-inertial frames. Non-inertial frames, they are also known as accelerated frames, or you can say them accelerated frame. Accelerated frame. ठीक है? Then, what is the meaning of inertial frames? Meaning of inertial frame is very simple. If this is a frame, and in this frame there is an object, this is X, this is Y, O, and there is an object here. Suppose this is an object, and on this object, force acting is zero. No force is acting on it. How can you check either a frame is inertial frame or non-inertial frame? Very simple rule is there. If no force is acting on this object, then acceleration of this object will be zero. Then what will be the acceleration of this object? Acceleration of this object will be zero. So this type of frame in which if net force acting on an object is zero, then acceleration of that object may be zero. ठीक है? So how can basically when you are saying that no force is acting on it, it may be at rest. So if it is at rest, it will remain at rest. Or second, if net force acting on it is zero, it is also possible that it is moving with a constant velocity. ठीक है? So if net force is zero, then it may move with a constant velocity. In that case, it will continue to move with the constant velocity and acceleration will be zero. So this type of frame in which if net force acting on an object is zero and its acceleration is zero, then that will be called as inertial frame. So this person is observing from the frame itself that net force on it is zero, then acceleration will be zero, then you are going to say this frame is inertial frame. But if you look at non-inertial frame or accelerated frame, then what will you observe? That suppose this is a frame, ठीक है, and an observer is here, and what he is observing that in this frame there is an object on which net force is zero. ठीक है, no force is acting on it, net force is zero, but even after f is zero, even after this, its acceleration is non-zero. Its acceleration is non-zero. Then this type of frame, they are called as non-inertial frame. They are called as non-inertial frame. So in the non-inertial frame, how can one check either this frame is non-inertial? You can very easily find out. Then choose an object on which net force is zero. Net force acting on it should be zero. And if you find out even f is zero, still it is having some acceleration, non-zero acceleration, then you have to understand that this will be a non-inertial frame. This will be a non-inertial frame. If you are having inertial frame, then in this inertial frame, Newton's laws of motions are applicable. In this frame, Newton's laws of motion are applicable. Motion are applicable. And here you can observe that no force is acting on it, but still there is acceleration. So this is violating the this is violating the Newton's laws of motion. What Newton's law says, okay, if no force is acting on an object, then it will continue to be in the same state. If it is at rest, it will continue to be at rest. If it is moving, it will continue to move. It will continue to move. ठीक है. Or F equal to ma, you are saying F is 0, but still A is non-zero. So here in this type of frame, in non-inertial frames, Newton's laws of motion, they are not applicable. They are not applicable here. So basically, when you are solving a problem and you are using Newton's laws of motion, then you need inertial frames. Here I cannot apply Newton's laws of motion. Okay, this is one thing. So now I will try to explain you non-inertial frames with the help of examples. Very simple example, example one of non-inertial frames. Example one. Suppose you are having this block. This is a larger block. Okay, and you have placed this block on a surface, and this surface is smooth. I'm saying this is a smooth surface. Smooth surface. ठीक है, this is a smooth surface. You apply a force on it. You are applying a force on it, or you are moving this with an acceleration a, whatever is this. ठीक है, and what you observe. So suppose in place of force, assume that this block is moving with an acceleration a. ठीक है, here I am saying this is moving with an acceleration a. I am saying this is block a. ठीक है, here we are having another block. You are having another block B, and I'm saying this surface, ठीक है ना, surface which is contact in between A and B, this is also smooth, so there is no friction. A smooth surface, both the surfaces are smooth surfaces. ठीक है, it is like this. So when you will and your observer is here, and where is the observer? Observer is standing on A. If observer is standing on A, then try to understand this frame of reference. ठीक है ना, frame of reference of A is accelerated. So frame of reference is accelerated frame. He is in the accelerated frame. This observer is standing on an accelerated frame. ठीक है, so for this person, this is an accelerated frame. Now try to understand this block is moving in this direction, and because this is a smooth surface, so this will be at rest. This block B, it will be at rest. So what will be the acceleration of B with respect to A? What this observer is going to observe? Try to understand this lower block is moving in the forward direction with an acceleration A. This block, because surface between them is smooth. So what this observer is going to observe? It will observe that this frame, from his point of view, from this person's point of view, what he is going to observe? He will observe that this block is moving in the backward direction with an acceleration A. This is at rest, no force is acting on it. Try to understand. On this block, there is no force that is acting. ठीक है, so try to understand. Here, no force is acting on it. ठीक है, no force is acting on it. But if this person is looking, ठीक है, after some time, what is going to happen? This B will be as the same place. This A will be here. So after some time, this will be the situation. So with respect to lower block, with respect to this block A, this B block is moving to the left with respect to the lower one. So what this person is going to observe, actually he will observe that this block is moving in the backward direction with an acceleration. Acceleration. ठीक है. So why this acceleration A, ठीक है, x why this acceleration A is acting on it, because my observer is in the accelerated frame, from where observations are made from the accelerated frame. So in case of accelerated frame, when observations are made in the observation or in the in the accelerated frame or non-inertial frame, what you are going to do, you will apply a force on this B in the opposite direction of this acceleration. So what will the direction of this applying force? That will be opposite to A. This will be A and mass of this block B. So for this observer, because this block is moving in the backward direction, so why it is moving in the backward direction? From his point of view, because this block is having an acceleration in the backward direction, so there should be a force that should be act on it, and that force will be how much mass of this block and into this acceleration, in which direction this force is acting. This force is acting opposite to the direction of the accelerated frame. The acceleration of this block will be equal in magnitude. Both A are equal in magnitude, directions are opposite, and multiplied by this. So what this will be, this is called as pseudo force. What do you call this as? This is called as pseudo force. This force is not actually, ठीक है ना? Actually, this is not present. But why this is coming into the picture? Because there is a relative motion B and A, and who is observing? A person is standing on A, who is in the accelerated frame, because he is observing. That's why this pseudo force is coming into the picture. This is not a real force. This is not a real force. Remember this. Pseudo force is not a real force. ठीक है? It is appearing. ठीक है? It is a apparent force. Why it is apparent? Because my observer is standing on the accelerated from. So it is appearing for this person that this block is having an acceleration in the opposite direction. So if it is having an acceleration A in the opposite direction, what is the force that should act, which is responsible for this type of acceleration according to this person? That will be mass of this block B into A. And this force is called as pseudo force. Okay? So whenever you are making observations in the accelerated frame, then you apply a pseudo force, and after the application of the pseudo force, okay, which is a fictitious force, this is not a real force. After the application of the pseudo force, now you can apply the Newton's laws of motion. You have converted what you have converted here by the application of this, you have converted this frame into inertial frame. Earlier, this frame was accelerated frame. Your observer was in the accelerated frame. Even no force was acting on it. If you look at this, net force acting on it was zero. But according to this person, it is having an acceleration in the backward direction. In the absence of the net force, it is having an acceleration in the backward direction. That's why this frame of this observer is non-inertial frame. So what is the solution? How can we solve? So that is very simple. We are creating a source for this acceleration. How much it will be? In which body acceleration is taking place? In B. So I multiply this acceleration with the mass of this body, and I apply a pseudo force over it. Now there is a cause. We are saying that this block B is having acceleration in the backward direction. This person is saying this person is moving, this block is moving in the backward direction due to this pseudo force. So you have created a cause, ठीक है ना, due to which this acceleration is coming into the picture. This cause is not real, but you have, ठीक है, knowingly you are introducing this cause so that we can apply Newton's laws of motion. So whenever you will solve a question in a accelerated frame, then by using the pseudo force, one can change a non-inertial frame, one can convert a non-inertial frame into inertial frame. Okay? So pseudo force is not a real force. You can write here pseudo force. Pseudo force is not a real force. Is not a real force. ठीक है. Number 2, pseudo force is used when observer is in an accelerated frame. Is in an accelerated frame. ठीक है. When observer is in an accelerated frame. To convert this accelerated or non-inertial frame, this accelerated frame into inertial frame, we use pseudo force. ठीक है. We use pseudo force. So what pseudo force is doing? Pseudo force is actually converting, ठीक है, known inertial frames into inertial frames ठीक है, in which we can apply Newton's laws of motion to solve the problem. ठीक है, to solve the problem. I'm giving you one more example of this pseudo force. Another example of this pseudo force is, suppose you are having a string, you attached a stone with it, a body is attached with it, and it undergoes this type of circular motion. ठीक है ना? This is a string, so automatically a tension is going to act like this. ठीक है, a tension is going to act like this. So this tension is acting in the inward direction. So two type of observers may be there. Suppose your observer is standing on the earth. Where? So he is standing on the earth. He is my observer. What this observer is going to say? This observer will say that this mass m, it is undergoing circular motion. ठीक है. So what this person is going to say that this mass m is undergoing circular motion. Is undergoing circular motion. ठीक है. And centripetal force required for this circular motion. So for circular motion, what is needed? For circular motion, centripetal force is must. There should be some source of centripetal force for the circular motion. So who is going to act here as the source of centripetal force? So this tension T is there. So what you are going to say here, for this type of circular motion, this tension is going to act as the centripetal force. In this way, you are going to explain this circular motion from here. ठीक है ना? From here, you are going to explain this circular motion in this way, that this tension in the string, that is acting as a source for centripetal force, and this object of mass m, it is undergoing circular motion. That is okay. But if you look from another point of view, so what is acceleration that is acting on it? acceleration is AC. Here acceleration is AC. Okay? Try to understand. And what is the value of this centripetal acceleration? AC, that is acting inward, and this will be equal to V square upon R. So a net acceleration is acting on it in the inward direction. I am considering uniform circular motion. So this acceleration AC is acting in the inward direction. Okay? Try to understand. Now, try to think this problem in another way. Now suppose my observer is standing on this. Okay? Here my observer is standing here in the frame that is attached with this ball. So you are having a frame which is attached with this ball, okay? And this person is standing on the ball or something. You can say this person is standing on the ball. So now, what type of frame on which, what type of frame is this on which this observer is standing? That is an accelerated frame. So this is second observer. Try to understand. This is first observer. This is second observer. So second observer is where? Observer 2 is standing in an accelerated frame. In an accelerated frame. Accelerated frame. So his frame is accelerated frame. Try to understand. So because throughout its motion, a centripetal acceleration that is acting inward. So this is always acting inward. That's why this is accelerated frame. This is accelerated frame. Now, what will be the observation of the second observer? What he is going to say about the motion of this ball? This observer will say, because he is standing on the ball, ठीक है ना? This observer will say that the ball is at rest. What will be his observation? He will say the ball is at rest. The ball is at rest. Try to understand. So in this frame, ठीक है ना? What he is observing that tension is acting inward. This is a real force. This is a real force, but still even in the presence of this tension, even in the presence of the tension, this ball is at rest from this observer, from the point of view of this observer. So what this observer is observing, he is observing that okay, throughout its motion, tension is always acting inward, but still the ball on which I am standing, that ball is at rest from my point of view. That will be even after the application of the force, no tension. That force is tension, no acceleration, ball is at rest. So this is how can you justify this? So problem here is he is in the accelerated frame. Why this type of controversy is coming into the picture? Because he is standing on an accelerated frame. So how can you solve this problem? Because he is in the accelerated frame, so he will consider a pseudo force in this direction. He will, what he is going to do, he will apply a pseudo force in this direction. Pseudo force in this direction. What will be the direction? Direction will be opposite to the acceleration of this frame. Acceleration of frame is inward toward the center O. So direction of pseudo force will be in this direction. And how much it will be? This will be mass and amplitude of the acceleration will be same. So this will be how much? This pseudo force will be m v square upon r. So in the outward direction, you have to apply a pseudo force, and this pseudo force will balance this tension that is acting in the inward direction. So what this person, how can he will justify? How can this person justify that this ball is at rest? He will apply a pseudo force in the radially outward direction. radially outward direction, and he will say that this tension is actually balanced by this pseudo force, and this will be mv square. Pseudo force is mv square upon r, and this is balancing this t. What you call this mv square? The pseudo force. When you are solving the problem in the accelerated frame, you are applying a pseudo force to balance this tension T so that this ball is at rest according to the justification of this person. You call this pseudo force a centrifugal force. So centrifugal force is actually a pseudo force that is that is acting in the opposite direction of the acceleration of this non-inertial frame in the radially outward direction, and we call this as centrifugal force. ठीक है ना, we call it as centrifugal force. ठीक है, so centrifugal force, this will be equal to mv square upon r, and this will be in radially outward direction. This is a pseudo force. So basically, to explain an event in an accelerated frame, we need a pseudo force. We need a non-real force which is not actually existing to justify whatever we are observing in that accelerated frame. So to justify whatever is happening in that accelerated frame, we are going to use this pseudo force. So this is not a real force. Just to explain the experience, the observation of the person in the non-inertial accelerated frame, we have to use this pseudo force. So this is the meaning of pseudo force. With the help of these two examples, ठीक है ना, you will be able, hopefully, you will be able to understand pseudo force. Is it clear?
Yes, yes, sir.
Good. Next, suppose another example is this. Suppose you are having this is a bus or something like this. This type of bus is there, and it is moving in the forward direction with an acceleration a. If a simple pendulum, you attach just 1 second. If you attach a simple pendulum here with the roof of this bus, if I attach a simple, so if this is at rest, try to understand, if this bus is not moving, your pendulum will be here in the vertical direction. Okay? But when it is moving in the forward direction, try to understand your pendulum will be like this. Pendulum will make some angle in this direction. In this direction. Okay? Pendulum is like this, like this. Now, how can you explain this? This will be theta. How can you explain this? Next question is, how can we explain this position? It will be at an angle with respect to this. With respect to this, there it will be at some angle. So how you are going to explain this? Next question is this. बोलिए. So try to understand in two ways you can explain. Suppose you are standing on the earth. Observer is standing on the earth. Observer is standing on the earth. ठीक है? This angle will be a real. Either you explain you are observing from inside the bus or outside the bus, angle is not going to change. ठीक है? So observer is standing on the earth. How he is going to explain this? This? How he is going to explain this? So his explanation is very simple. What he is going to say he will say that a tension is acting. Tension is here T, and I can resolve this tension into two components. One component will be in this direction. This angle is theta. This will also be theta. Okay, so this will be theta. So what will be this component? This will be T cos theta. And another component will be this, and this will be T sin theta. T sin theta. And weight of this ball or pendulum, it is going to act in the downward direction. So which two equations? He's using only real force. From here, when he is standing on the inertial frame, he will real this observer who is in the inertial frame, he is going to observe only real forces. So what he has to explain? He has to explain this phenomena with the help of real forces only. So real force is tension, real force is weight. So only these two forces he is using. And he will say that this T cos theta, this T cos theta, it is balancing the weight, mg, of this bob. This is called as bob. Second, this T sine theta, this is an unbalanced force, and this T sine theta, it will cause an acceleration in the forward direction, and acceleration will be A. So he will explain like this. So he is going to explain like this. So this T sine theta, because this block is also moving with the same acceleration because it is attached with the bus, so automatically whatever this angle is, continuously it will move in the forward direction with the same acceleration. So he's saying this T sine theta is actually responsible for this acceleration A. Okay? For this, so divide these two. What you are going to get? If you divide these two equations, you will get tan theta. And that will be A upon G. A upon G. ठीक है ना? That will be equal to A upon G, tan theta. So this will be. So this is the acceleration. From here I can find this angle. If I know the A and G, if I know A and G, then I can easily find out. I can easily find out this angle. Is it okay? This is one point of view when you are observing from the earth. So this is the explanation that is from the earth. ठीक है? From the inertial frame. From the inertial frame. This is the explanation. Next, now we need another explanation from a point of view of a person who is standing on the bus. Who is standing on the bus. So here his explanation will be different. So suppose a person is standing in the bus. This will be A, acceleration will be A, and now my observer is here. ठीक है, my observer is here. So next question is how this observer is going to explain. ठीक है ना? Now from his point of view, I need an explanation. So here I'm using different color now. Now position will be same as observed from the earth, so it will be theta. So what this observer is going to say, this observer is in accelerated frame. Where is he standing? He is in non-inertial frame. He is in non-inertial frame. Non-inertial frame. First thing. Second, what will be his observation? He will say that, okay, because he is in the bus, he's saying that this this string is making an angle theta. That is okay. But after that, it is at rest. He will say that this ball is at rest. However, this string is making an angle theta. Because why? Because this ball is at rest with respect to this person. ठीक है, try to understand. Angle may be there, but ball is at rest. What will be his observation? His observation is Ball is at rest. Is at rest with respect to me. With respect to me or observer. So this will be the second aspect. Now he has to explain why it is at rest. So again, tension is there. So tension is there. This is T. This angle will be theta again. So this will be T cos theta. Real force is another real force is mg that is acting in the downward direction. And this will be T sin theta. So this is unbalanced force. Try to understand this is unbalanced force. So from his point of view, it should move forward, but it is not moving. This block is at rest. So why it is not moving, or how this T sin theta is balanced? Because of that pseudo force. So because he is making observations from the pseudo force, ठीक है, so you have to apply from sorry beta, this observer is in the non-inertial frame, so whenever you are observing the thing you have to consider this pseudo force. In which direction you are going to apply pseudo force? Acceleration of the frame is in plus x direction, so this will be in minus x direction. So this will be a. What will the mass of this block? That is m. So this will be ma. So what is this? This is pseudo force. And now look, when you consider this pseudo force in this direction, then this pseudo force is going to balance this T sine theta. And this T cos theta will be balanced by this mg. So net force on it will be 0. Now net force acting on it will be 0. And when net force is acting on it 0 in this frame, okay, so he can justify that, okay, it will be at rest. So how he justified his observation that this ball is at rest? By using this pseudo force. So here this ma, okay, the pseudo force is actually balancing this T sine theta, and this T cos theta is balancing the weight. If you divide this, then tan theta will be A upon G. Both the theta will be same because that is a real angle. Real observations, they are not going to change. Okay, angle is a real observation, so that is not going to change in either way you are solving the question. Either you are solving in the non-inertial frame or in the inertial frame. That's your choice. Physical physical quantities, they are not going to change. So this is the way. So if you want to solve a problem in the non-inertial frame, you have to use a pseudo force. Okay? You are going to use a pseudo force. Now suppose there is a block that is placed on this inclined plane. This is an inclined plane, and this inclined plane is moving in the forward direction with an acceleration b. With an acceleration b, it is moving. So how you will write equations? Okay? So here this is b, and you are making observations from here. So some observer is here. So this will be, so what you are going for this observer, weight will be there, mg will be there. If this is theta, then this will be theta, and this will be mg cos theta. Mg cos theta. Mg cos theta. And normal reaction will be there, and a component of this mg will be in this direction. This will be mg sin theta. Sin theta. When you are doing calculations from here, you are standing on an accelerated frame. then you have to apply a pseudo force also, because try to understand when the block is going to move in this direction, sorry, when this inclined plane will move in this direction, this block is also going to move in this direction. ठीक है ना? So basically here, to consider that aspect that this person is standing here, so you have to apply a pseudo force in this direction. What will be its magnitude of the acceleration of pseudo force? This will be B here, and mass of this block, that will be M. That is going to be M. So these are the forces which are going to act. And suppose this is a rough plane. So because if this is a smooth plane, try to understand when this is a smooth plane, this block will move in the expected motion will be in the downward with respect to this frame. So what will be the direction of the pseudo force? Pseudo force on this block is going to act opposite to the expected motion. So these are the forces which are acting on this block. Okay. So if there will be a question and you have to solve that question in the accelerated frame like this, then you have to use this MB in this direction. Remember this aspect. How you are applying the direction of the friction force, that is very simple. Assume that this surface is smooth. If this is smooth, no acceleration will be there. In which direction you are expecting motion? Due to this mg sine theta, you are going to expect in this direction. So automatically friction force will oppose this motion. So direction of friction force will be this one. So in this way, you can draw the diagram. Okay? You can draw the diagram. Another. Okay? Another example of the pseudo force. Here, this is a lift here, and this lift is having an acceleration in the downward direction. There is a weighing machine you have placed here. Okay? This is weighing machine. A person is standing on it. A person is standing on it. So whatever weight will be there, whatever weight this machine is going to show, that will remain same. Either you are explaining this event from Earth or you are standing in the lift. Either you are standing in the lift or you are standing on the Earth, you have to explain whatever weight is shown by the machine. So from the Earth, if observer is on the Earth, how will you explain? If observer is on the Earth, is on the Earth, is standing on the Earth, okay, then how will he will explain? He will say that, okay, weight of this person is going to act in the downward direction. I have earlier discussed this, and this weighing machine, it is going to exert a normal reaction over it. Okay, because downward motion is, this is the downward motion, so mg will be greater, only then downward motion of this person will take place. So mg, weight of this person, opposing force that is opposing the motion of this person in the downward direction will be n, and this will be ma, net acceleration in this direction. So you are going to say that this n will be equal to m, and this will be g minus a. So this will be the reading of the weighing machine. ठीक है ना? This will be the apparent weight, and this apparent weight will be shown by this weighing machine. So this is the explanation when your observer is standing on the earth. But now suppose my observer is standing inside the lift. Try to understand. ठीक है? My observer is here. Same problem is there. But my observer is here. ठीक है? You are assuming that observer is here. So observer is inside. ठीक है? So observer is inside the lift, and he should get the same result because weight of that person is not going to change. So now he has to explain how he can explain the weight of the person. Okay. So he will say that, okay, I am standing what this person is saying. He will say that, okay, I am standing in a non-inertial frame. Non-inertial frame. I have to do calculation in non-inertial frame. So I will apply a pseudo force on this person. What will be the pseudo force? Pseudo force will be in the direction opposite to the acceleration of the frame. My frame is lift. Lift is having acceleration in the downward direction. So he will apply a pseudo force here. A will be the acceleration and m will be the mass of this person that will be in this direction. Second will be the normal reaction because this person is in contact with this. So a normal reaction will also act on it. And mg is acting downward. For this observer, this person on the standing machine, on the person standing on the weighing machine is at rest. Is at rest. Is at rest. According to this person. So he will say that upward forces are balanced by the downward forces. So what are the upward forces? He will say n plus ma equal to mg. And this will be n. That is the reading of this. That will be mg. Bring this ma on this side. So this will be ma. So this is the reading of the weighing machine. So in this way, this person inside the lift is going to explain the reading which is shown by this weighing machine. That is shown by this weighing machine. This will be. ठीक है? It is another example. It is another example, beta. Please note it down quickly.
सर
Yes, beta.
सर प्रीवियस एग्जांपल में जो इंक्लाइन वाला जो क्वेश्चन मतलब एग्जांपल कराया सर
हाँ
उसका
बेटा.
इक्वेशन एक बार बता दीजिएगा सर।
क्या बेटा?
कौन
क्या? What I want to tell you?
सर कौन सा जो फोर्स है वो कैसे मतलब इक्वली मतलब कौन सा बराबर हो रहा है आपस से
No,
एम।
actually, I will solve this problem later on, where this block may be at rest. You may find out the acceleration when this block will be at rest. ठीक है? Or it is moving with some acceleration downward. I will come to this problem again. I just here was showing that this will be the direction of the pseudo force. I will come to this problem. I will explain you.
यस सर वो एम बी जो लगा है सर उसमें थोड़ा सा कंफ्यूजन हो रहा था बस।
Why?
वो एम बी लगा है ना सर स्यूडो फोर्स उसमें थोड़ा सा
Yes?
कंफ्यूजन हो रहा था कि वो कौन से फोर्स को मतलब इक्वेट होगा उससे।
No. No, I will balance it. ठीक है? So this n will be balanced like this. This n is going to, you can resolve this n. N is here. So you can resolve this n here. So this is theta. Theta, this will be 90 minus theta. So you can have this n. This is theta. This is 90 minus theta. This is theta. Theta here. So this will be 90 minus theta, or you can say this is theta. So here this will be n cos theta. Sorry, n sin theta. If you want to balance this, I have written in all possible direction. And here it will be n cos theta. N cos theta. So basically you have resolved this mg that is balanced by it. But actually, if you are saying that it is not moving in the downward direction, then you have to consider, ठीक है ना, forces in this direction. One force is this F, another is this mg sine theta, and there will be a component of this mg also in this direction. So I will come to that. ठीक है? So in this way you can resolve If you need to resolve, try to understand this is 90 minus theta. And how should I make this parallel? This is parallel. So this will be theta. I have resolved all the forces for you. So in this direction, this will be MB cos theta if you need. And in this direction, this will be MB sin theta. MB sin theta. So here I have resolved all the forces. So whatever will be the question, on the basis of that question, we are going to use the component. Okay, I will come to this problem later on. I will discuss this. ठीक है, suppose a block I have capped on a frictionless surface. ठीक है, so next example is, suppose this is an inclined plane. Its angle of inclination is alpha, and you place a block here. ठीक है, you place a block here. So you can write a block is capped on a frictionless inclined surface. Please write a block is capped on a frictionless inclined surface as shown in the figure. As shown in the figure. Full stop. The incline is given. The incline is given an acceleration A. The incline is given an acceleration A to keep the block stationary. This incline is given an acceleration A to keep this block stationary. Then A will be equal to, then what will be the value of A? You have to find out. This will be G upon tan alpha. G upon tan alpha. Option B, that will be G cosec alpha. Option C, this will be G. And option D, this will be G tan alpha. You have to find out this. ठीक है ना? You are going to find out this. So how will you find out? You have to find out this acceleration A that is given to this inclined inclined block in the forward direction, so that it should remain at rest. And this surface is smooth. Try to understand, this surface is smooth. So how can you do this question? So here first you have to show all the forces. One of the force is acting in the downward direction. This is mg. Mg. So with respect to this block should not move with respect to this inclined plane. I am not saying that this block is not moving with respect to Earth. This block is moving with respect to Earth. Try to understand. When this inclined block will move forward, automatically this smaller block, it will also move forward. But it should remain at rest with respect to inclined plane. So block A, you can say block A should remain at rest, should remain stationary, should remain stationary with respect to inclined plane. So who is your frame of reference? Who is your frame of reference? Your frame of reference is inclined plane. This is my frame of reference. Frame of reference. And what type of frame of reference is this? Frame of reference. And what type of frame of reference is this? This is accelerated frame or non-inertial frame. You want to solve the problem here in non-inertial frame. So you have to understand. So you can say my observer is here. If you just want to have a person as observer, then person is here. This is just assumption that person is here. I'm not saying because its weight will be in picture. I'm not saying this. So in this direction, so mg is here, a normal reaction is going to act on it, it will be in the upward direction. It will be in the upward direction. And third force will be pseudo force. Because you are doing calculation in this frame, so this will be here. Mass of this block is m, and direction of the pseudo force is here. So this is pseudo force. This is pseudo force. Okay, this is alpha, so this will be alpha. Alpha. So I resolve this in this direction. So if this is alpha, automatically this will be alpha. This will be n cos alpha. And what this will be? This will be n sin alpha. N sin alpha. So this n sin alpha, this is going to balance this m. So n sin alpha is going to balance the pseudo force ma, and this n cos alpha, that is going to balance this mg. So divide these two, so this will be tan alpha and this will be a upon g. So what this a will be? This will be g tan alpha. So this is going to be g tan alpha. So this should be the answer. So correct option should be g tan alpha. ठीक है? So correct option will be g tan alpha. ठीक है? So if someone asks you, so this will be. Now if someone asks you how much force is applied on this so that this acceleration is created, ठीक है? Mass of this is m. ठीक है? This is a question. If I ask you what is the force, you also calculate the force. Also calculate the force. Force so that inclined plane is moving with an acceleration a, with an acceleration a, with an acceleration a. You have to find out. So force will be equal to mass into acceleration. ठीक है ना? Who is responsible for this force? That will be F. This acceleration is created, but acceleration is created together. Mass of this is m. Mass of this inclined plane is this capital M. So force will be equal to capital M mass of inclined plane plus mass of the block into this A. And this will be G tan alpha. So I can write M plus M into G tan alpha. This will be F, beta. This will be F. So, is this okay with everyone?
Yes.
Good.
Sir,
Next. Yes, beta, please.
can you please teach that force, how
Which one,
how
beta?
we should calculate force?
Pseudo force.
F is equal to cap cm plus small m into A.
Okay. Force is how much, beta? Force is mass into acceleration. If mass is not changing with time, mass into acceleration. Okay, so I want to find out the force that should I apply here so that this block is moving an acceleration A. So I want to find out this force. And what is the acceleration that is created? That is A. So this force applied, it is taking these two, this inclined plane plus this block. this system together in the forward direction with an acceleration a. When this block, this inclined plane is moving forward, this is small block is, it is also moving forward with an acceleration a. So together this system made up of this inclined plane and block, together it is moving forward with an acceleration a. So what is the mass? ठीक है ना, that is moved forward by this force, that is m plus m. So this is the total mass that is moving forward with an acceleration a. So that's why I'm writing F equal to m plus m, total mass of the system into a. Is it clear now? Hello? So this will be, please write another example or
सर
question you can. Yes, beta, please.
सर इस केस में जो mg को क्या रिजॉल्व नहीं किया क्योंकि इसमें फ्रिक्शन नहीं दिया है।
Because friction is not there. When friction will come, we will again think. ठीक है?
ओके।
So next, suppose I'm having this type of, suppose this is a block like this. I apply a force on this block, F, it is moving here. A pulley is, a pulley is placed here. Pulley is placed here. Now two blocks are there. One block is here. I call it as A. It is attached with a string, and here there it is attached. Another end of this string is attached with another block B, and this block is in contact with this larger block. ठीक है? It is in contact with this larger block C, and masses of this is, this A is M, mass of this is M, mass of this is 2m, and mass of this is 4m. ठीक है ना? 4m is the mass of this larger one. So please write the question. Find the magnitude of F. Find the magnitude of this F. F for which. Find the magnitude of F for which the blocks A and B will remain at rest. Find the magnitude of the force. Find the magnitude of the force F for which blocks A and B will remain at rest with respect to block C, with respect to block C of mass 4m, with respect to block C of mass 4m. So four options were there. First was 4 mg. Option B, 9 mg. Option C, 14 mg. And option D, 17 mg. And 17 mg. ठीक है, these are. ठीक है ना, these are the options. So please solve this question. Try to solve this question. So these blocks should be at rest with respect to C, with respect to block C. So what you are saying, block, you are saying that block A and B should remain stationary, should remain stationary with respect to block C. ठीक है ना? respect to, with respect to this block C. So who is frame of reference? Block C is frame of reference. And because force is acting on it, it will have some acceleration. So basically here, ठीक है ना, try to understand here, this is an accelerated frame or non-inertial frame. Non-inertial frame. Non-inertial frame. ठीक है, so here, ठीक है ना, non-inertial frame will be there. So first I assume that, ठीक है ना, non-inertial frame will be there. So first I assume that, ठीक है ना, non-inertial frame will be there. So first I assume that, ठीक है ना, non-inertial frame will be there. So first I assume that, ठीक है ना, non-inertial frame will be there. So first I assume that, ठीक है ना, non-inertial frame will be there. So first I assume this block C. So I'm assuming this block C is moving forward with an acceleration A. Okay, this is the acceleration of this block C. So try to understand, I have to apply a pseudo force on it in this direction. So that will be mass of block A. Okay, and this, what will be this? This will be A. This is a pseudo force. On this B, a pseudo force is going to act it, and that will be 2m. Mass of this B is 2m, and that will be A. Okay, this will be. Now, other forces you are going to apply. Tension force is acting in this direction. Here, its weight, mass into G, m into G, and this will be normal reaction, N1. So I can write N1 is equal to mg, first thing. Second, this tension, this will be equal to ma. ठीक है ना? This will be ma. Try to understand, it is at rest. It is stationary with respect to lower, so net forces which are acting on it, they will be balanced. So I have balanced these forces. Okay, because this is stationary. So these two equations I have created. Second, if you look at this B, okay, weight of this is acting in the downward direction, 2 mg will be there. Tension is acting in this direction, T. So second equation will be T is going to balance this 2 mg. This is for mass A. This is for mass B. And second, because it is in contact with this, so it is going to exert a normal reaction N2. N2. So this N2, that is going to balance with this 2Ma. If you combine these two together, tension, that will be equal. So this Ma, that will be equal to 2 mg. So what will be this A? A will be equal to 2g, mass will cancel out. So what is the acceleration of this C so that this will remain at rest? That will be 2g. 2g. Now what will be the force? What is the force F that you are applying so that this block C will move with an acceleration A? So try to understand, this block is not single. On this block, two blocks are attached also. A and B, they are also attached with this. So together all three will move in the forward direction with acceleration A due to the effect of this F. So it will be equal to mass of A plus mass of B plus mass of C. I have shown you in the last class that finally A will be F upon M1 plus M2 plus M3. Similar type of thing is here. Now substitute M, 2M and 4M. So it will be how much? This will be M plus 2M plus 4M. And what is acceleration? Acceleration is 2g. So this will be 6 and 7. 7 to the 14g. 14 mg. So this will be the force that should be applied. So if we are going to apply this force 14 mg, then this block A and this block B, they will be at rest. They will be stationary with respect to this C. So with respect to this C, they are going to be stationary. Beta. Okay? So if you apply this much of force. So today I'm going to stop here, but in the next class, okay, I will discuss a few questions and then I will again start discussing work, energy and power with the collision. Okay, and from tomorrow we will have optics class. I will start interference also on Monday. Okay, we will start. Okay, this optics, wave optics. Okay, beta. Thank you very
Sir,
much.
please show the second slide.
Okay, beta. Just I can show you all the slides.
सर मैंने ऑप्टिक्स की जो क्लास है उसको रिकॉर्डेड ले लिया, तो कल की क्लास लेना पड़ेगा?
No, you can skip. ठीक है ना? You can skip that one. So this is the first slide.
ओके सर.
Second, third, fourth, sorry, it's quick. This is third. This is third again. Fourth. Then fifth. Sixth. Seven. And this one eighth. So these are all the slides. ठीक है बेटा. Okay बेटा. Thank you very
Thank
much.
you,
Good
sir.
night. Welcome
Thank you,
बेटा.
sir.
Welcome बेटा.